So who here has experience building charts with D3? Who has tried building charts with D3? Okay, and who uses React? Okay, so I'm Alberto Restifo. I work as Synthesis. We are building LangAI, which is a system for natural language understanding and intents extraction from text. We analyze text and we extract intents. And this here I had to create many charts because we have dashboards where users can ingest this data. And some of them were simple line charts, like this one with some interaction. It's also responsive. Some of them were a bar chart. This is also responsive, and it has some interaction, like you can see here. It's not, yes. Then it is another example of a fully customized animation. This is built with D3 and React 2, where it's to demonstrate the connection between the concept in the center and the outer circles. It's not visible in the projector, but there are some lines animating out of this. And lastly, there is this bubble chart, which is pretty big, and users can zoom in, interact with it, and click on these bubbles to view the details. So all of those are built in React and D3. So how? I couldn't use an existing library. By all means, if like a library like Recharts, which is the most popular one, already does what you need, you should use that. This is not meant to be a better, like an easier approach than Recharts. This is only when you need to do something that is customized, when you want it to be integrated, and you have your needs that are not fulfilled by a simple library like this one. So the simplest approach for integrating D3 with React is by using ref and just copy and pasting essentially the code from blocks. Maybe you know about this website is where you have examples of block code, and actually this talk is based on the example of this line chart right here. Some of the code you will see when I reference original D3 code is actually just straight from this example. And so the way you will go about this is you will render an empty SVG, put a ref that stores your container element in as a class property, and then on component did mount, you will call a function to render your charts, and here you will put your copy-pasted D3 logic. And this works. This gets the job done. It's fine. If it's something like a one-off project, this will probably do what you want. But we're here to speak about the right way to do things. So the main problem is that both D3 and React are two DOM libraries. They both want to handle the same thing. They both want to manipulate the DOM. And this is what happens when they try to do the same thing. Let's say in your D3 chart, you're running an animation, or you're putting event listeners. You must be sure to remove the listeners when the components are mount, otherwise you're creating a memory leak. Normally, React will handle that for you. If you are doing something else inside the render function, you need to handle this yourself. Then reacting to updates of state is more complex, because you will be calling the same D3 function multiple times, and you need to make sure that it behaves correctly with new states, and this can be complex depending on what you want to do. Handling interaction, again, it becomes more complex because React kind of lives in its own little world. Sorry, D3 kind of lives in its own little world where you can have these click listeners that are connected in this case to the circles in the line chart, and then you can trigger your action. But again, it's not very integrated. And then if you want to add tooltips, that's where things really go bad. Like you need to inline HTML. And I mean, this is just miserable at this point. So we can do better. The trick is to create the SVG with React and use D3 to compute the graph. D3 has a lot of math helpers, and use those to compute the graph instead. Now we will see a little bit of code. The important thing is not to try to understand every line of code. It's more, the code is there to help you understand the concept behind the idea. So this is what we'll be creating, which is a representation of my stress level as the talk approaches. This is yesterday, where I didn't finish the talk yet, but today is fine, because the talk is amazing. So this is the actual chart, by the way. We also have tooltips on over and stuff like that. So this is what we are going to build. So let's start by the actual SVG. This is how you will do it in the D3 example, which you are just selecting the container element that we've stored in the reference, in the render, and then you are creating a group and appending with a transformation to put some margin. If you don't know why we use transformation for margin, is so the coordinates in the chart are going to be still the point 0, 0. It's going to still be the top left corner, and we can put margin by translating the group afterwards. So we can do the same thing in D3 in React pretty easily, right? We can just manually write out the SVG, pass in the transformation, and this is absolutely the same thing as before. So then we need to add the path of the line. This is from the D3 example, the D3 code. It might look familiar. You have a function to draw the lines where you pass the accessors to the data, and then you pass the datum to the path, and you add the styling to your path. So if you look at the line drawing function from D3, which is from the D3 shape package, it's pretty straightforward. It returns a line generator, and we can pass to the function some data, and it will return a path, an SVG path. And we need to specify X and Y as accessors to the data points in our line. So we can just use that straight away. We have our line drawing function, and we simply call it with the data, and we will get back the string of the path, and this will work. We will have the same result as before. We need to do an optimization though, because here we have a problem. This computation is happening on render. This is very wasteful because the render in React is called many times, even if maybe nothing changed, because a child might have an update and we need to call this. So instead of calculating the line on every render, what we can do is we can pre-calculate it when the component mounts. We can simply pre-calculate the line and store a version of the data in the state, which already has the X and Y values. This is simply the scales for actually creating the chart, the line. At this point, the only modification we will do to our line function is that instead of calling X and Y to scale the values, we are simply directly accessing them from the data. If you want to add the points, again, that's the example from D3, which is for every point in the data, we are iterating and adding a circle. So again, pretty simple, just iterating and adding a circle. Let's make a point component with D3, with React, sorry. So we are splitting things up a little bit. It's a simple component which accepts the data as properties and returns a circle. And then in our render function, this is the render function of our chart. We simply iterate the data, and for every element in the data, we render a point. Pretty straightforward. Same as D3 before, we are just typing it out manually, basically. Now, if you want to add the tooltip, that's where things start to get really good and exciting for this method. Because this is the mess that is the D3 example. It's just awful. I mean, what is this? We're inlining some HTML inside of a React, so we can add a div on mouse over, but we're doing it in React. So let's just define instead a tooltip component. Our tooltip has two properties, hidden and the data set. When it's hidden, we remove the opacity, and we translate it in the position of the data set that we receive, and we just render our tooltip. In this case, it's pretty simple, but you can scale it up as much as you want. Then we add it to our chart. Just note that we're also wrapping the SVG element. We are wrapping it into a div. That is, because our tooltip will need to be positioned with position absolute. And to make it easy to work with, to use the same coordinate as the chart, what we can do is we can wrap in a div where we specify the same width and height of the chart and position relative. What happens now is that the 0 point for both our div and the SVG actually is the same. So basically, our divs acts as another pane for the axis and the coordinates of the chart. And then to toggle the tooltip, we just had on mouse enter, on mouse leave, callbacks on our point element, pass them correctly, and that's it. The tooltip is done. Now, for the axis is maybe the only place where things are more complex instead of, and not as straightforward for D3. Because in D3 you have some rendering, some function that you just pass the data, and they return you an already built SVG group that contains the axis. But the downside is that in D3 you don't have any customability. So instead we can manually build our axis, and there are some methods in D3 that we can use to help ourselves. This is from the package D3 array. Extent simply returns the maximum and minimum value of a data set. Ticks is interesting because it returns an array filled with values from start to stop every count, but the values are already nicely rounded, and it handles dates, it handles pretty much everything. So we would use them this way, like we pass to extent, we pass our data set, for example, the date, and then we get the values, like in this case we will get a day every 5 dates data points in this data set. So for example, to build, this is the actual code of the chart. If you want to build the y-axis, we are accessing the data. We take, in this case, because the y-axis is on a fixed scale from 0 to 100, I'm just passing 0 to 100 and getting a point every 5. Then I'm scaling the y value. So we're scaling the y value in the same way we scaled the chart data. And in the actual render, what we do is we iterate the data, and we position, using top, we just position the text of this data point at the correct height, because the coordinates of our container div match precisely with the chart. It means that this is correctly aligned on the left side. Then we can just include the axis after our chart and tooltip in the same wrapping div. And that's it. Basically, this way we reproduce the entire chart as the D3 example. What would we earn by adopting this approach, right? The first thing is now we can actually render the chart on the server, because we are not relying anymore on the DOM. There is no need. So if your app is server rendered, normally if you use D3, you will need to wait for it to render. And in this case, it will already be there for the users. As Synthesis, we're actually using that to put our line charts in PDFs. So it's pretty neat. Then modularity, because instead of having one huge block of D3 code, which is messy and difficult to maintain, now we can split it up into components, right? We have a component for the point, a component for the tooltip. We can make a component for the line. Depending on how complex your chart is, you can make as many components as you want. Is React. And then it's extendable because you are in full control, right? You're not limited by a library or by those capabilities. It's React. You can do whatever you can do with React. Performance is also quite good, because particularly now with React 16 and React Fiber architecture is really, really fast. And I didn't manage to create some performance numbers, but between the D3 algorithm to update the DOM and the React Fiber, we're close. And then just some React love, because it just works. If you add mouse listeners, if you're running animations, because it's another React component, it will correctly amount. You get all the lifecycle events. So when you update states, it's very easy to handle. So now let's make it beautiful. Let's add some nice animations. So this is what we want to do. We want to animate the line. And we want also to animate the points, so they have like a nice bounce feeling, and it's very smooth. This is just an iframe, so as you can see, it's perfectly smooth and 60 FPS, and it's not difficult. So the first approach, the simplest, is to just use CSS transforms. In this case, I'm using them for the tooltip, the little opacity. This is just a CSS transform, and this is super straightforward. Like in our tooltip, when we just put a transition for the opacity. When the hidden will change, our opacity will transition using the browser. But when we need to do some more complex stuff, like in the other two cases, D3 provided us with some timing functions. The first one we can look at is timer, which is part of the D3 timer package. Basically, this is a wrapper around request animation frame, where timer will call your callback at the correct time across browsers to make your animation as smooth as possible in 60 FPS. And in your callback, you will receive the elapsed time since you started the timer, and you manually need to stop it. So this is an example of how you use the timer, which is you set a duration, and once you do your stuff in the timer callback, and you check if the elapsed time is greater than your duration, you stop the timer. This optional value here is because you can delay the start of the timer by a given amount. This will come handy later. Then we need also an ease function to give a nice curve to our animation. There are several of them in the D3 ease package. All of them share the same API, which is a function that accepts a number between 0 and 1, which is the point in your curve at which you are. And you have different easing curves. The one that I'm using in that example is cubic in, which has this shape, and is elastic, which has this woo bouncing. And this is what we are using for the points. This is for the line. Next up, we have interpolate number, because as you noticed, this function needs a number between 0 and 1. And our timer gives us a duration in milliseconds. So we need a way to obtain these numbers and to get the correct values of what we are trying to animate. And to do that, we use interpolate number. We simply you pass A and B, and then you get a number between 0 and 1, which is exactly what we need. So this is how you use all of those together. You have a duration. You need a linear scale for your timer between 0 and duration. This is pretty important to clamp it, because when you clamp it, it means that it won't go, your scale won't go above your value here. So for example, if you pass it, let's say your duration in this case is 1,000 milliseconds. If you pass 1,500 milliseconds, it will return 1. It won't go above 1. Then we start our interpolator. This is for in this case, is for the points. So we're interpolating the radius of the point between 0 and 4. And then for every tick of the timer, we get the elapsed time. We scale it, and we pass the scale value to the easeElastic out easing function. From that, we pass our value that we got of the easy function to our interpolator, and that's our new radius for the animations. It's important to stop the timer after you run your logic, otherwise it might happen that your last step won't run. So it might happen that, for example, in this case, the radius of the point would be below 4. Another thing another tool that we can use is the transition group from React to coordinate the animation together. Recently, they changed the API of transition group. When I last used it, it was simpler. Now they divided it out of the main package. It's called React Transition Group. Before it was in the React add-ons. And you have two components, transition and transition group. So the way you will use it is, in this case, I'm wrapping the point with a transition component, which gives us our onEnter callback that we need to start our D3 function, D3 animation function. And then we wrap all our points, we wrap them in a transition group. And this is very important, because transition group, by default, we render a div, but we cannot have a div inside of an SVG, so we need to specify the transition group to render a group instead. Please note that I'm passing the index as a key. Sometimes it's an anti-pattern, but sometimes it's not. Because what happens is, if you pass a unique ID to in this case, to the point, what will happen is when you get new data, even if a point is in the same position, because you are changing the key, React will transition it out and back in. If you're instead using as a key the index of this value, If this point is not changed, even if its ID is changed, it will instead maybe shift position or do something else instead of just going out and back in, because because React will not replace this point. And that's it. That's how we get a 60 FPS animation. There is no like hidden magic or some very complex stuff. It's just calling some functions and it works. Yay. So the question is now, well, wait, we can go and take a look at the full code of that animation. So this is the line chart. In the line chart, what I'm calling is when the components mount, I'm calling the transition path with a little bit of a delay. And in the transition path, to animate the path in an SVG, what we want to do is we want to set an offset of the path. So in this case, we can see it here, the stroke dash offset. That's how you do a line animation, a line drawing animation. If the offset is the same as the length of your path, the path will be invisible, and then you gradually reduce the offset, and you are drawing out your line. So that's what we are doing in transition path. As seen before, we are scaling the timer between 0 and our duration. We are interpolating between the path length and 0, because we want to reduce the value in this case. And then for every tick of the timer, using the is function, we scale the time, we get the value of the offset, we set it in the state, and that's it. This is just because, so the animation is looping, so it's irrelevant, it's just for the demo. And this is for the line. As far as the point goes, the full code is here, which is like before. In this case, it's fired when handle enter is called by our transition group, is the one that is calling the handle enter at the correct time. And in this case, you are doing the same as before. We have the duration, we are scaling the time, we are interpolating between 0 and 4 because 4 is our final radius. And this is maybe the interesting bit here at the bottom. We want every point to start at a different time. So I'm just multiplying 80 milliseconds for the index of this point. So if this is the first point, it will be 1. If it's the second point, it's 2. And this way, every timer will start a little bit later. That's why it's handy to use the D3 timer function. And that's it, basically. That's all the code for that animation. So how does it scale? Yes, it does scale, but it has a limit. It does not go forever. So, for example, this chart that I've shown you before, this is actually not built this way because there are too many points. The zooming and panning interaction was not fluid enough because you have a problem that you're updating the position of the chart so often that the React internals becomes your bottleneck. So what I did in this case, I used a canvas. This is actually code from the chart. I'm passing a ref to the canvas, and then I'm drawing the graph in a canvas essentially every time, iterating the nodes and drawing every node. And for handling the zoom or the pan, I'm bypassing React internals by just setting the value of the transformation in a class property instead of in the state. This way, I don't need to have the state updates running, which will need that it means that it calls many methods. It calls should component updates. It calls component will amount, component will receive props, no, component will receive props, component did update. This way, I'm bypassing all of those and just directly drawing the graph, and it did the trick. That said, there are still some performance considerations that we want to take into account when doing this. The first thing is we want to use pure component. Does everybody know here what pure component is? Have you heard of it? Essentially, by default, in a React component, you can specify a should component update function where you receive the properties, the new properties, and if you return false, the component does not trigger the render function. A pure component is available as a React export, is React pure component. And basically is a React component that implements should component update, and it checks for every property if they're shallow equal. So if none of the properties change, your component is not rendering again. I think that sometimes will actually happen in a normal component. Because we want to render our graph as few times as possible, because our render is now the actual frame of the animation. So the less it happens, the better. So you need to keep shallow equality in mind, so you will avoid wasted renders. So can anybody tell me what's wrong in this example? What we can do better? So the thing is, in here on the mouse handlers, we are directly passing a functions. And this means that every time the render function runs, we are creating a completely new function, and the shallow equality will fail because this new function is not equal as the previous one, and every point will render every single time, even if the data is identical. It's easy to fix. We just need to pass a function that is on our class instead, and instead of, like before, passing the data point from outside, it should be the point component that is calling those methods with the data we want. That way, this function will always be the same, and we are avoiding a lot of renders, many of them. Then you want to keep render lean. You don't want to do complex calculation inside of render, because again, it's particularly in an animation, every render is a frame of your 60 FPS, and you have 60 milliseconds to render it, otherwise you will not hit 60 FPS. So like in the example before, you want to move all the computation in when the component receives properties and put them in the states, and then directly access them from the state. The more you put in the state and the less computation you do in the render, the better it is. Then you should prefer small components, because React is very good with reconciliation. So if you have many small components, React will know exactly what to update. If you have one single huge component that renders many things, it will update many more things at the same time. And so that's it. That's how we made our charts with React, how we made it work, how we animated, and that's it for me. Do you have questions? Something you need clarified?
The code will be available?
Yeah, everything is in our repository. Oops. This entire code base, the slides, and the actual example that you have seen running is all here, is all available on the GitHub. I will tweet the link. And
see, you have data JSON now. In that example, you guys are server-side rendering. Where are you pulling the data in from?
When we're rendering it from the server, we are fetching the data from our API separately. First, we fetch the data, and then we pass it to the components in the server when we're rendering it. In this case, the data is fixed, so I'm just requiring it in the actual line chart. Where is it? No, in this case, it's in the app. Oop. In the app, I'm just requiring the data, parsing it to a date, and passing it to the line chart here. So if that's it for everybody, it was a bit short.